Hello, Year 13. This slide shows about Lewis structures. We did some work on Lewis structures last year. This year we're moving on a little bit, but from what we learned last year, but it's very similar, you'll find. So reviewing what they're all about, Lewis diagrams or structures are diagrams to show the bonding between atoms in a molecule or an ion. So we're talking about polyatomic ions now. They also show any lone pairs of electrons that may exist in the molecule, and we use dots to represent the electrons. And of course, they're all valence electrons. We're ignoring the inner shell electrons for this. There are single bonds, double bonds, and triple bonds involved sometimes. A triple bond is the sharing of 3 electron pairs, a double bond is 2 electron pairs, and a single bond is 1 electron pair shared between 2 atoms. The rules are similar to what we learned last year. I won't go through them again. You can look at the slideshow later if you like. Just be aware of the exceptions. Beryllium has a full shell with only 4 electrons. Boron has a full shell with only 6. There's 3 pairs. And then we also have the molecules that can take more than 8 electrons around them. So they can have what they call an expanded octet. And any element in group, in period 3 onwards can do that. So let's look at the Lewis structure of a polyatomic ion, the ammonium ion. If we count up all the electrons like we did last year, everything is the same as we learned. Okay, nothing more there. This is a new thing here, though. That when you find that the ion has a charge, in this case it's the a positive charge, that means it's missing 1 electron, and so we have a -1 in the calculation for that. Okay, so first of all, we arrange the symbols. In the middle goes the atom that has the biggest possibility of gaining more electrons. So you might remember nitrogen has 5, so there's room for accepting more electrons there. So first step is we allocate 1 pair per bond, and then in this case that's the end of it really, in the sense that we've allocated all the electrons. The only extra step that we have to make here is the fact that we put these brackets around the ion and show the charge on the outside. Okay. What about the Lewis structure for phosphorus pentachloride? Well, we do follow the same process. We notice that it's not an ion, so it's a molecule. We don't have to do the charge thing this time. So we go through here and we work out that we have 20 pairs to allocate. We put phosphorus in the middle because it has room for more electrons to be bonded to it. In this case, phosphorus has 5 valence electrons. So you might say it's got room for 3 more, but in actual fact, phosphorus can have an expanded octet, and that's what we see this time. So we put the chlorines around the phosphorus like that, then we allocate 1 pair of electrons for each of those. So that's 5 pairs gone, 15 left. Now you'll notice if you put 3 around each of the chlorines, that's another 15 electrons. So we've used up all the electrons there. And that is the Lewis diagram for phosphorus pentachloride. Notice the expanded octet around phosphorus with 1, 2, 3, 4, 5 electron pairs. Let's look at the ICl- ion. Now this time it is an ion, and in this case it's a negative charge. So instead of taking 1 away, we're adding an electron now when we're doing our summing up of electron pairs. And so we end up with 18 pairs, but then we go through the same process as last time. Put the bonds in here after we show the arrangement. Then we add the other outside bonding pairs. And notice this time we have to add another two pairs of electrons around the center atom, because we've got another two left over after we've added the lone pairs on the chlorines. So this ion has 4 bonding pairs and 2 lone pairs around its central iodine atom. How did you get on?